Okay, well, hope you guys all had a good break. We're going to get going again with Joel Humphries from the Colorado State Office, who will be talking about the integration of AIM into the NEPA process. So thank you, Joel.
Thank you, Sarah. Good morning, everyone. I'm going to pretty much try to tell a story that my co-authors and I worked on, Zoe Davidson and Ben Billings, about an AIM project that started in the San Luis Valley field office back in 2015. And the story I'm going to try to tell today is about how we use that data to come up with a permit renewal process in the valley. And at the same time, the actual intent of the AIM project that started in the valley back in 15 wasn't to address this specific allotment in any way. It was, originally the data was collected in a way to answer questions about the solar energy zones there and potential mitigation sites, and along with a small sliver of sage-grouse, Gunnison sage-grouse habitat in the northern end of the valley, and that species actually is threatened. So we kind of had this, how do we actually do this moment after collecting a couple of years of data in the San Luis Valley? It was kind of like, how do you actually come up with a framework to take that data, to repurpose it when it wasn't, you can do that with the AIM data. That's one of the nice things about it, is you can collect the data once and you repurpose it to answer different questions. But there's still some questions. How do you take the standardized data that we've collected and then put that into a permit renewal process? But it does help provide consistency too with this framework that we're trying to establish here to answer these questions in terms of NEPA. And one of the challenges in the San Luis Valley is we did not have ecological site descriptions to come up with quantitative benchmarks to really appropriately apply this quantitative data. So we came up with this method to actually use these, what I'm going to call ecological site summaries, that kind of will work in lieu of absence of ESDs and other ways, and then kind of bring that, analyze the data and bring that into, land health, looking at land health standards to see if we're meeting or not meeting our habitat objectives. And also, again, as people have mentioned, with this quantitative data, in case you do have areas that are more contentious, you do have a little bit, better, footwork or, standing as far as making your decisions through the process. So one of the other things that's currently going on in the BLM right now is we've got this streamlining NEPA question that we're also trying to answer, and the AIM data can also be used to help streamline the process. This is a result of one of the recent secretarial orders as well, to help this process along. And again, this is like one of the nice things about the standardized methods that we have with typical, the same indicators and being a repurposed data, so you don't have to keep on collecting the same data again and again, or not necessarily the same data, but different data. Is that structured implementation that Emily talked about earlier today, as far as you think about what you're going to do, off in the future, into the distant future, so you're not collecting right, the 22nd hour. It's also that streamlining process with NEPA. It's going to be a little bit more transparent as well. So this framework I'm talking about has essentially, we came up with 6 different steps to implement this entire process. I'm going to hit on the first 2 here real quickly. Over the 6-step process, the first 2 I'm going to talk about is determining an area to be assessed, and then how did we determine the benchmarks. I kind of alluded to that a little bit earlier. We did not have your typical traditional ways to establish benchmarks, to take quantitative data and actually kind of establish a threshold to see if we were meeting or not meeting. So in the case of this permit renewal, we looked at this large, it's actually a Huck 8 watershed level. We took a large number of points within this area, and we have roughly, I think, 46 points in the predominant strata that we used for the analysis in this case. Where we have 2 strata, basalt hills and limey bench, that made up the majority of allotments. So we were interested in the strata that were within that Clover allotment. So we have this kind of comparison going on. This larger area where we've got the blue area, that's the Huck 8, and that's kind of smaller area on the screen as well, as far as that red area on the screen. There's the allotment that we're interested in, and we did do some targeted sampling and intensification of the allotment, and we have overall 13 sample points over several years. So I've kind of talked about this benchmark idea. You also will hear this again today, this concept of benchmarks. And, well, what is a benchmark? It's really a way to take this quantitative data and compare something like foliar cover, for example, if you know you have X% of foliar cover, is you're taking something that's an observed value and you're comparing that to an expected value or desired conditions on the landscape. More specifically, for example, you could write this benchmark in a very concise manner, and the better, if you can do it in concise manner, the better the benchmark's actually going to be, because it's really achievable. Specifically in this case, we wanted to determine whether foliar cover was greater than or equal to 30 to 60%. So we came up with this range, and we came up with a confidence, because we can calculate that with the AIM data as well. We wanted to know that with 80% confidence across 80% of the watershed and 80% on the allotment, with in respect to both of to each respective strata. So the next kind of little conundrum we had was actually in the valleys I previously mentioned. A lot of times you have other policies out there, such as maybe sage grouse. You have reference sheets, you have ESDs, you have all this information typically to pull data from, or to set your benchmarks. In this case, we didn't have any biological vineyards. There's no T&E species there. This was predominantly a terrestrial system in a very dry environment. We're talking 5 to 7 inches of precip, so barely, almost really any ephemeral drainages even. So we didn't have water quality standards. We didn't have any of that. But after collecting data for several years, we started to take this AIM data and also some other data as well. Maybe it will be mentioned as well, the landscape monitoring framework, which is collected by NRCS, it's the NRI. We actually used that data to help to also establish these benchmarks. We came up with what I'm calling these ESSs, environmental site summaries. It's kind of a surrogate for these ESDs that we used as well. And I'll be talking about how we actually created that a little bit today through the process. And another way we could also establish benchmarks would be through looking at the data through frequency distributions. Either the ESS or the frequency distribution is really an empirical-driven method to actually establish these benchmarks. So in the case of the San Luis Valley, I just pulled up a number of different indicators here actually, and as I mentioned, we just basically did some quick descriptive summary statistics that anybody can really do in Excel. These functions are just in there, so you can just take your data, you pull it out of Terradat or your DEMA. Terradat's the terrestrial AIM database where all of the AIM data resides overall. But then you can just take some simple summary statistics, and you can take your average. You can look at your distribution of data. You can look at your quartiles. You can do this with box plots. You can do it more of a numeric fashion as well, looking at first and third quartiles. How is the data distributed? You can look at things like standard deviation. Do you have a large range of variation with your data? Things like that. And in the case in the valley, we looked at specific indicators for this land health summary, like bare soil, foliar cover, things that are relatively easy to calculate and are done through the line point intercept method. So actually, if you could kind of remember some of those actual values in the last one, we did take based on that data and professional judgment. We always did describing indicators of rangeland health actually in the San Luis Valley as well. So we're starting to does the data actually reflect what we're seeing on the ground in terms of ecological processes? Or we don't want to necessarily include data where we're looking at degraded sites. So we're also kind of passing the red face test. As far as we wanted to include data that was truly representative of a functioning ecosystem too. So we didn't necessarily want to either include data that wasn't truly representative of conditions we're trying to manage on the landscape. But essentially, we came up with these benchmarks I'm talking about earlier, and 30 to 60% foliar cover with 80% confidence over 80% of the area. And bare soil, typically we did not ever see bare soil in places that bare soil was typically represented in an area that was relatively functioning at what we kind of thought was at a good level and was less than 20% typically. So we just kind of did that for all these different indicators, and this is the process. We document the benchmarks to establish. I'm sorry. So the next step in the framework is actually to collect, once you establish the benchmarks and determine the area to be accessed, I'm just going to really lightly touch on. You also then just need to collect all your different monitoring data as well. That's relatively straightforward. I don't need to go into great details about that. But once you collect all the different monitoring data that you have, you're going to start summarizing that. You're going to take that data, summarize that into a land health report. And the land health report is going to use this concept, the multiple lines of evidence. It's been, BLM has done this for years and years and years. We don't want to just necessarily take one type of data or one piece of information to inform a decision. So we're going to take the AIM data that we've had. We are going to kind of run that through, do a benchmark analysis, and also look at our ecological site summaries. But you're going to do this with an ID team. That's very important to remember as well. This is not just done in a big black box. It's done as with an ID team. You can also then potentially look at use-based monitoring, interpreting indicators range on health and PFC as well. To, overall kind of, always keep in mind we're looking at site potential when we complete the land health report. And eventually, if you do this right, you're also going to potentially help inform your whole NEPA process. In the case of in the land health report, if we find out we're not actually meeting our land health standards, we would also then potentially have to go into causal factor analysis. Something to keep in mind. And now, in terms of the valley, it's kind of a story between this one allotment down on the lower screen there versus the up top where we have this allotment compared to the watershed, and we did have kind of you can just see visually, but there's a difference. But we wanted to not just base our decisions on, oh yeah, this looks bad, this looks good, So we did want to take this data, this quantitative data, and actually start reporting, kind of at that watershed level and at the allotment level. We just kind of did, again, some simple descriptive statistics and those ESSs. And actually a box plot would probably be a little bit better, more appropriate way if we're going to do a comparison between the allotment and the watershed. You would take the watershed data and the allotment data in two different box plots and actually look at how each one of those different indicators is different from one to another. That'd be a good way to just kind of do it graphically. So after you summarize, go through, and come up with a land health summary report, you're going to then bring that into what we do in the BLM a lot, and that's NEPA. That's National Environmental Policy Act for people that are not familiar with that. That's really how we kind of base a lot of our management decisions in multiple use agency is through going through the NEPA process. So this is taken right out of the BLM manual. This is the NEPA flow chart here. And, very early on, this goes back to Streamlining NEPA. If you do a land health summary report and you do it correctly, you're going to actually help streamline the NEPA process because the land health report is going to inform the NEPA process right at the beginning of everything. You're going to start looking at, you can take that into what's the purpose and need statement. From that purpose and need statement, you're going to help inform your range and alternatives. We're kind of going to this new issue-based driven NEPA in BLM as well in the streamlining process. We're only going to carry, issues that we're identifying, things like the land health summary report. So we're going to sometimes, in some cases of our NEPA process, we're just going to reference our land health summary report, not necessarily carry that into the NEPA so we have shorter, more concise documents, but we do reference it. We've done the work. We just have to make sure that we reference it in the NEPA process here. So again, just touching real quickly on the purpose and need. You can potentially use quantitative benchmarks even in the purpose and need statement. It wouldn't necessarily always be as applicable in a grazing permit renewal, but if you're doing a treatment, that's absolutely a place where you'd start. If you're doing a treatment on the ground, like juniper removal or a seeding treatment, you would write quantitative benchmarks, respective, like if you want to remove juniper, you want to see, X percent on the ground. If you're doing a seeding treatment, you want to see so many, perennial grasses or forbs come up. And again, this is going to, feed back into those range of alternatives as well and making it concise. Now, the next step in the NEPA process is going to be coming up with the affected environment. Again, this is where you can take the land health summary report. These things keep on almost getting nested. In the land health summary report, we're going to have this kind of these quantitative benchmarks again, this quantitative summary report in your land health summary. And you're going to just bring that right into the infected environment. We're going to kind of talk about, hey, how much bare ground do we have? In this case, how much surface rock fragments, total litter, things like bare soil. You can see, like, hey, on average, we've got 12%. Based on our, benchmarks, we're talking about the watershed at that level. Well, we want to see going back, it's less than 20%. So you can kind of just, quickly looking at the infected environment, realize that you're, roughly, you're meeting those standards. You're kind of within that range you want to be. Again, the whole process is somewhat iterative as well. And the next step is then you're going to start analyzing if you gather new data in the for the analysis or the alternatives, you may need to do analysis on the alternatives as well. And now the team with the National Operations Center has come out with actually some pretty handy tools, and one of them is the terrestrial benchmark tool. And I've been using that a lot lately, actually more specifically for sage grouse. But what we're taking basically in the terrestrial benchmark tool, it's a Excel spreadsheet, and you just basically input your benchmarks or your management objectives into a spreadsheet. In case of this watershed, we want to, this kind of range of 30% foliar cover, 60% foliar cover. Once you put that in, actually with the data you've collected, then you get a quick little summary report that's produced, reporting summary report in the benchmark tool. You can kind of see, like overall, if we're talking about the watershed, we're achieving our benchmarks. But when we start looking at the area in the allotment, and based on the photos you saw, you might anticipate these types of results. We've got a lot of bare soil. We're not meeting the standards typically. We don't have the amount of perennial grass that we typically have. And this is actually about, this is about where the field office is currently at in this process, is they haven't quite finalized. They haven't gone through all these different decisions yet and, finished the grazing permit renewal. But at this point, they're going through the impact analysis. They're sitting down as an IDE team, and they're talking about, I think they have determined at this point they're not meeting the standard based on the results that we've seen, and they're starting to move forward, and they may be needing to consider a change in management decision, but they are also have to do something like causal factor analysis. First, maybe looking at use-based monitoring, things like that. And then the last part is based on whatever the decision is. Again, you go through the entire NEPA flow chart. Once you make that decision, and I apologize, I keep on hitting the back button. But after you make that decision, regardless what it is, you continue to monitor. And with the AIM process, you will kind of have the sample frame of repeating past points. So you have that ability, whatever the management decision is, to monitor into the future. Are you meeting the objectives you said you thought you'd meet in your NEPA decision document? That's important to remember, just kind of always making sure that you're achieving those standards into the future. Any questions? Morning.
Forgive me if I missed this, Joel, but I'm still a little unclear how you chose what, the good sites were, objectively chose what these good sites were as opposed to stretch marks.
That was the entire. That's the art to the science.
Yeah.
And we did look at overall. The big thing was taking. It was empirically driven. So we took a bunch of the data. We looked across the entire field office within those data, and kind of noted, okay, in our sites, we see this kind of like this range. We kind of restricted to a certain percentage of plots. So we kind of did like the quartiles, and we looked at our standard deviation and then also standard error too. As well, and kind of, based on that on those results, we set our benchmarks from that.
So it's kind of like you have your highest, let's say, percentage sites, and then your lowest. And then
Correct. Yeah, that's you could say it like that. Absolutely. So if we went out to a site with perennial grass and we see on some sites it goes up to maybe 70%, but we maybe start seeing less diversity or something, maybe because the grasses are out competing other things that, maybe that's not necessarily desirable. So it is kind of like this preponderance of evidence approach still at the same time to determine that. So you don't want to just look at the data, but you have to kind of, that's the art of taking all these different indicators and looking at it holistically at the same time.
Mm-hmm. We do have one question from the WebEx.
What definition of invasive are you using?
Now, currently, the interesting question, I don't know if they know how timely this is. We are now in Colorado have gone to using our watch list to define invasives, the ABC noxious weed list, along with the watch list in Colorado. And one of the main reasons why we're doing that is it's legal. It's also, that you've got the support of, there's been input by multiple stakeholders and we're not necessarily just looking to introduce species. And that gets into, I think, a very gray area as well. And people that have on the AIM team are well aware of this. This was kind of a recent decision to kind of shift that way recently, is to go towards the noxious weed list.
All right. Thank you very much, Joel.
Thank you.